Hey, Miss Sparks.
Hey, how are
How are you?
you?
I'm good. How are you?
Good.
So I had some questions about when I'm doing the holes the um with the graphing and everything like that.
Yes, sir.
So when I'm trying to find a hole, Miss Murphy was kind of explaining it to me yesterday.
Uh-huh.
So I take out I take what was crossed out in the equation, like so when I'm factoring or whatever. So like you have like for example, x plus 3 over x squared minus 9. And I'm going to take the x plus 3's. I'm going to cross those out.
Hold on.
Okay.
Let, let me write down exactly what you're saying so that you and I are tracking
Okay.
together. Are you working on a particular worksheet?
I'm working on the homework 7.
Oh, homework 7.
Yes, ma'am.
All right. Do you want me to pull it up?
If you don't mind, you can.
Okay. This is it, right?
Yes, ma'am.
Okay,
It's
cool.
problem number 4.
Okay.
So when I factored it out, I was left with 1 over x minus 3.
So these two crossed out and then you are left with this.
Yes, ma'am.
So the whole is going to be where you'll set this part, the x plus 3 equal to
Mm-hmm.
0, so you get x equals -3. So that is the that's the x coordinate, right?
Yes, ma'am.
Okay.
And then I got for my hole, I got -3 and then 1/2.
Now you plug that -3 back in to the simplified equation.
Yes, ma'am. That's what I did. I plugged
So
it into
1
the.
over -3 minus 3 equals 1 over -6. Right?
Oh, I plugged it into top and bottom. That's what I thought Miss Murphy was telling me to do.
Well, you would plug it in if there were X on the top.
Oh, I'm so confused by this part.
Okay, sweetheart. Let's let me see if there's another let me look for a different hole. There's another hole on the graph. I'm just looking through all the problems, okay?
Okay.
Because you're right. If there was an X on the top, you would plug it into that.
Yeah.
I mean, just I'm looking. Sorry.
No, it's all good.
But there wasn't an X on the top of this one. So I'm going to switch over. I'm looking through to see if there's any. There was another hole on this particular one. We did it in class yesterday. No, we didn't. That was a different one. I can't remember. We did so many off and on.
Okay, how do you graph a fraction?
Oh, Lord. Painstaking measures.
So, because like I don't how do I
Okay.
graph 1 over -6?
Yeah, like what I would do, like 1 over -6. I mean, like that's like tiny. You know what I mean?
Yeah.
That is let
Just
that
like
is like
I need to know like the general place where it goes. You know what I'm saying?
Right. It's literally point 0.1 something. So on these itty bitty graphs, bless your heart, and that's what I was thinking. Some of these I was working on, I was like, the graphs are so little. But
Mm-hmm.
basically, oh Lord, everything went away. Okay, there we go. Okay, so on that, you've got -3. So I'm going to count over 1, 2, 3, right?
Mm-hmm.
And then this is like literally point 0.1.
I'm not seeing. Oh, there you are.
There, yeah. That's how itty bitty it is. Like you can't even hardly show it on this graph. You know what I mean?
Yes, ma'am.
So that's what you're going to do. It's just a hole right there.
But do I have to put my graph through that?
I mean, like it could not run through that. Does that make sense?
Because like, can I show you what I have on my paper?
Yeah. Hold on.
Okay.
Let me switch back over because I can't see my worksheet and you at the same time. So yeah, let me see.
Okay. Hold on. I'm gonna try to make it to where you can't see me because I don't want you to see me.
I understand. I don't want
Okay.
you to see me either. Which one are we
So,
working? We're working on 7, right?
number 4.
But worksheet 7, we're working on number 4.
Yes, ma'am. So like, is that correct? Like the hole right
Actually,
there?
you know what? The other thing, yeah, you actually, I think you did better than I did. I
Oh,
don't know. Did you
really?
change your increments?
What's that mean?
Oh, it's not at the top. I did something wrong. It's a -1/6. Then I graphed it as a positive. So please forgive me.
It's all good.
It's actually down here.
Oh, so that makes more sense. Okay, okay.
Yeah. So like when your graph, if I'm not mistaken, this one, what's the vertical asymptote on this one? Let me double check. It's x equals what is it? X equals 3, right?
Mm-hmm.
So we got 1, 2, 3. Like that.
Mm-hmm.
So your graph basically, and then the horizontal asymptote is y equals 0. So your graph is going to be rolling, rolling, rolling. Boom. Got to skip over that part, rolling, 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 and then goes down, right?
Yes, ma'am. That's what I got.
Yep. So that's all
Okay.
you're doing is just showing me that there's a hole there. And I am not going to be picky when it's -1/6.
Okay. Because like when I was working on other problems, I was like, some of these are way off, and I'm like so confused, and
Yeah.
I don't know.
And I actually had a XY table for this particular one. So that I would have some very specific points, 1, 2, 3, 4, and then like this was a point here. And then I had 2, -1, which I didn't do very good. I don't think I kind of did. I did okay. That's like a specific point because I was trying to at least get 1 or 2. But anyway, that's what she's going to look like.
Okay. Awesome. Thank you, Miss Sparks.
No problem. So you would just show it like that. So something I wanted to show you about a hole, if you have just a minute, sir.
Yes, ma'am, I do.
I was going to show you one that where you had to plug it in at the top. So on number 4, I believe it is, on the graphing review, which is homework number 8,
Yes, ma'am.
that actually Lord Jesus, please be with Miss Sparks. X, so if I'm going to factor the top, right? So I've got x minus 6 over, oh, this is kind of a jank one, but anyway.
Wait. How did you get the -6?
-6 and
And then
-1.
X -1, yeah.
Yeah. So, and then these cross out with, like I said, this is kind of I'm not crazy about this one because then we basically have a line, but at the same time, that's technically f of x. My bad.
No, it's all good.
But the hole on this one, x minus 6 set to 0, so x equals 6, right?
Yes, ma'am.
So the x coordinate for the whole is 6. Then I'm going to plug that 6 into wherever there's an x, top, bottom, or both. And in this particular case, it's only the top. So the y coordinate is 5. So this thing is going to be some crazy line, right? Where it's going to have a hole at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And there's going to be a hole there. And it's a line other than that. Not a very
Okay.
good line here, mind you, but
No,
there's
no, no.
that hole.
And then your x-intercept.
Was that -1?
Oh, yeah, yeah. Okay.
Let me see if there's another hole. All the rest of them are funky graphed ones, but there are other holes.
Well, wait. That would be
What?
your y-intercept, not your x-intercept.
Yeah, y-intercept. I'm sorry. You're right.
So
Your x-intercept is -1 or is +1
+1, yeah.
because you set the numerator in this case, equal to 0, which is that, but you
Yeah.
would set.
Awesome.
Okay.
Yes, ma'am. Thank you.
No problem. Does that help?
Yes, ma'am, it does.
Okay. Number 5 has a hole where you have to plug it into the top and the bottom.
Okay.
Okay.
Yes, ma'am. Thank you.
Uh-huh. I do have a question. I had several people email me about a question on graphing review, homework number 8. Everyone, like literally 3 people emailed me and asked me to do, let me see, which one am I on? Number 7. But if there's any others that anybody wants me to do besides that, I can. But I'm definitely going to hit number 7.
I kind of just wanted to go through the whole thing.
Okay.
I'm not really. I've kind of been pushing math to the back because of other subjects, and I haven't really learned this concept very well. And
Okay.
And this one wants us to use the T table.
Yeah. And I've been doing some T tables for some of these because I knew that she did. So I will try to. A couple of them, fortunately, they're the number 7 is the worst. Number 7, yes, number 7 is the worst T table in them all. Number 6 is kind of rough. And I say that only because, I'm sorry, I say that only because there's so many fractions and decimals, it doesn't really distinguish what the points are. Does that make sense? I mean, they're so minuscule because of the fact that it's nearing the asymptote, which is the whole point of the asymptote. But I know that she wants you to do your T tables based on the critical values, which are the vertical and horizontal asymptotes, primarily the vertical asymptote. So, but number 1 and number 2, those are really fairly easy because those are just reciprocal functions. So what you're going to do on these is the reciprocal function, you're looking here.
What I'm basically asking for is if you can just go through these as if I've never heard of this before, so I can kind of relearn this because I'm really fuzzy on it.
Okay. Yes. The first number 1 and number 2 are reciprocal functions. And the horizontal asymptote, okay, a reciprocal function just looks like this. And the parent function is a -h and a +k. That's the parent function. And the horizontal asymptote is y equals k, and the vertical asymptote is y equals h. So in number 1, my vertical asymptote, because the original has a minus in it, I can see that these are very similar. So my vertical asymptote is going to be x equals 2. My horizontal asymptote, there's nothing there, so it's going to be y equals 0. So I will sketch those on the graph at x equals 2. And this is really what you need to know. That is primary. And then y equals 0 is just your y-axis. Your domain is going to be every real number except for 2. And your range is going to be every real number except for 0. With these two, 1 and 2, being reciprocal functions, the domain and range really corresponds and connects with, the domain connects with the vertical asymptote, and the range connects with the horizontal asymptote. And then does she want you to do t-tables on these as well? Because I'm just having my students sketch the graph knowing that you would normally, this would be in the first and third quadrant. That's not going to be the case on this because there's a negative.
Well, she's had us do t-tables for everything that I remember.
Okay. All right. So your critical point here is a 2. And there would be an error. And that's why you want to start there. So then you would want to go 2 up from that and 2 down. So you're going to plug in, obviously, and you understand why you couldn't plug in a 2 because that would give you a 0 in the denominator, and that's why it's a critical point. Mm-hmm. But if I plugged in a 1, 1 minus 2 is a -1, and a -1 over a -1 is a 1. So that point is going to be 1, 1. And if I plug in a 3, I've got 3 minus 2, which is a +1. So that's going to be 1, 2, 3. And then that's going to be a -1. How many points does she want you to get?
I don't really know. I think
because essentially what you need to know is that this is going to do this. I mean, that's what I'm asking my students is I need them to know that this negative flips it, reflects it across the axis, which normally a reciprocal function happens in the first and third quadrant. And because it's a negative, it's going to happen in the second and fourth. And that would give you enough points to be able to do that. Does that make sense to you?
Yeah, that makes sense. It's when you start getting to like, holes and all those other weird terms that it gets kind of confusing.
Okay. Hold on just 1 second. I'm sorry. I'm pulling something up. Okay. So, but this part seems to be okay, correct?
Mm-hmm.
Okay. All right. So for number 2, once again, this is a reciprocal function. So these are a little more straightforward in the fact that now we can identify this second part. That's going to be your horizontal asymptote. So that's going to be y equals 1. So it's exactly as it seems, okay? And your vertical asymptote is the denominator. Basically, a good way to think of this is exactly what would make that denominator 0? Like what number would I fill in for x that would make it 0? And that's going to be x equals -3. Because if I plugged in a -3 there, it would make it 0. So that's going to be where this graph is undefined. And then with regard to the domain and range on these, once again, pretty straightforward. Your domain is going to be every x value except for when x equals -3. And your range is going to be every y value except for where y equals 1. So those are the critical points when you're graphing these. The most important thing that you need to know are these vertical and horizontal asymptotes. Okay?
Mm-hmm.
Your graph is going to really then just hug these asymptotes. That 2 tells us that it's either going to be a little fatter or a little skinnier. So your XY table for these, once again, you fill in that critical point, that -3, all right, for your table. And then you want to put in your values for that. This would be undefined. And then you want to go up, a couple up from that and a couple down. So if I plugged in say a 0, that's going to give me 2/3. So that's 1 2/3. Right?
Mm-hmm.
And if I plugged in a 1, that's 2. 1 plus 3 is 4. 2 over 4 is 1/2. And 1/2 plus 1 is 1.5. Yes?
Mm-hmm.
Correct me if I'm doing my math wrong. Help a sister out. And then if I plug in a -1, -1 plus 3 is a positive 2. So that's going to be 1 plus 1, right?
Yeah.
All right. We sure I did all that right? Check me. Gotta love simple math, right?
Mm-hmm.
It's my favorite.
I did some other numbers. I did like -2.
Oh, you did? And what'd you get?
Is
Well,
that
that's fine. What'd you get? -2 what?
I got 3.
Okay, well, that's probably better than me. Okay, so if we go over 2, 1, 2, and up 3, these should hug the graph like that. We needed to pick some bigger numbers so I can get way over here. 1, 2, 3, 4, 5. What happens when I put 5 in? Gives me 1/4. So 1 1/4. So -5.
-4 gave me -1.
Okay. Praise the Lord. Love you, Momo. Be careful. Thank you. -4. 1,
I think
2,
that's what
3, 4. Good job, Garrett. I haven't done t-tables on all of these. I've done them now, starting with the ones going forward. I didn't do them on the reciprocal because I was just asking my students to sketch those. So good job on filling in your points. So on this next one, x plus 4 over 4x plus 12. The vertical asymptote, once again, is where you set the denominator equal to 0 and then solve to find out what would make that equal to 0, because you can have 0 in the denominator, okay? So that's going to be 4x equals negative 12 and x equals negative 3. So my vertical asymptote is x equals negative 3, which that's my critical point for my XY table. This also factors to be this. So that's how you get the vertical asymptote, is setting the denominator equal to 0. The horizontal asymptote is the one where you've got 3 different things that you compare your degrees of your variable. So like the degree of the x in the numerator is 1, and the degree in the x in the denominator is 1. So when they're equivalent, you take the ratio of the leading coefficient. So the leading coefficient on this x is 1, and the leading coefficient on that x is 4. So the horizontal asymptote is 1/4. Or, because it's easier to graph sometimes, although these graphs are so small, the fractional representation of 1/4 is 0.25. So my vertical asymptote is negative 3. So 1, 2, 3. And my horizontal asymptote, oh, have fun graphing this, is 0.25. So that gives me my rough start to my graph. Okay. A hole occurs when you can cancel something on the top and the bottom. That does not happen here. The x-intercept is when you set the numerator. So the vertical asymptote has to deal with the denominator. The x-intercept is when you set the numerator equal to 0. So that's going to be negative 4 and 0. Because the y coordinate for an x-intercept is always 0. That's why you set it the numerator equal to 0. So we can go ahead and plot that. That's negative 4. So 1, 2, 3, 4. So that's right there. Very close. All right. And now there are no holes, so we write none. Our domain corresponds to our vertical asymptote. So the domain is, I don't know, how is she asking you to do the domain and range? Are you allowed to do x such that x doesn't equal negative 3? Are you allowed to do that?
The way you've been doing it's the way that we've gone about it.
That's the way right there?
Yeah.
The way I just wrote?
Mm-hmm.
Oh, okay, cool. All right. And then the y is that, so that it can be any y except for 1/4. which it corresponds to the horizontal asymptote. And now for an XY table, that's undefined. So I usually use that as a starting point. And here's a fun thing. We can actually include our x-intercept on this one. And then I had -5, and that's 1/5. And I had -2, and that's 1/2. And I had 0, and that's 1/3. I actually had -8 also, and I believe that's 1/5. Oh, actually, my -5 is 1/8. And I did this because they were alike. And my -8 is 1/5. -8's 1/5. -5 is 1/8. And these were loads of fun to graph. So 0 and 1/3. Believe it or not, that is supposed to be above that. It's so hard on this one, you know, because that 1/4 is so, and then -2 and 1/2. And -4 and 0. So this actually does something like this. It just really hugs that asymptote. And then let's see, -8. These are all so close to this. I don't know how many points she wanted you to do, but they're just so close to the asymptotes. You know? What did you get? Did you have any other points?
I just put what you put down.
Okay.
I
I
don't know if I
mean,
would have been able to figure out how to graph that though.
well, I because they're so close to the asymptotes, but I don't know, like I guess you could pick 10. Let's see, what's 10 plus 4 is 14. And 4 times 30, I don't know. Any numbers I pick, I'm not doing a good job, I don't think, of picking numbers is another thing. If you put in 0, you've got, well, I did that because that's 1/3. I was just trying to figure out numbers that would go well, you know?
Mm-hmm.
See, -8. I did -8 because I thought I was just trying to think of other numbers and I wasn't doing a very good job. Those are the best ones, but the thing about it is they're all so close to the asymptote. When you're hovering around that undefined point, you know, your vertical asymptote, and you're only going a little bit away, it's just going to hover near that asymptote. That whole thing runs really, really close to the asymptote. So, and I think that's the key thing to remember, Garrett, is that these actually run very close to the asymptote. So if you have your X and Y table and you show those fractions and show, because basically a fraction is all going to be within, like that -8 is going to be within that box of the 1/5 or of the 1, and it's going to be just below that asymptote because we discovered that our 1/4 is where the asymptote is. So 1/5 and 1/8 are both less than 1/4 because if you did all of those in decimals, they're teeny tiny. Does that make sense at all?
Yeah.
Is she letting you all use your graphing calculators or no?
I mean, I'd assume, yeah. I don't know if she wants us to actually use the graph. Doesn't matter. I don't know how to use it to graph anyway.
Oh, okay. Okay. I'm trying to think of pointers and tips because I don't want to go against what she would have you all do. You know what I'm saying?
Mm-hmm.
Um, but at the same time, I want you to understand the concept. Um, do you have your graphing calculator with you?
Yeah.
Could you do me a favor? Which one do you have? Do you have a TI-84 or a TI-84 Plus?
I have the TI-84 Plus CE.
Okay. Can you hit the Y equals for me?
Yeah.
Okay, it should be flashing. Now hit. I'm going to tell you exactly what to type, okay? Open parentheses, X. Do you know how to do the X button?
Yeah.
Plus 4, close parentheses, divided by, open parentheses, 4x plus 12, close parentheses, and then graph. It probably looks a little wonky, but you can see that everything runs really, really close to what we had done as our predetermined vertical and horizontal asymptote. So that's why those lines just run really, really tight. And you can see that because of how little these numbers are. Does that make sense?
Okay, I'm
At
looking
all?
at it. I figured out how to get it to work, and it does show me. So I just throw in that, and I say basically the numerator divided by the denominator, and then it will tell me how to graph it.
Yeah, you just can't leave out parentheses. You have to remember those parentheses.
Well, I mean, yeah, I would just push them all together if I didn't do that.
Okay, yeah. So, but like I say, I don't want to go against what she has. You're still going to have to show your work for your T table. You know what I mean?
Mm-hmm.
So, but at least
is
you'll
the
know if
test
you
gonna be
got your
like,
graph. I'm
is
sorry?
the test gonna have like an X integer VA HA whole like blanks for that, or is it just gonna be solve this, graph it?
You're going to have to know like the x-intercept and the vertical asymptote and stuff like that. So if I can get you clear on those, and then you be able to at least sketch the graph, you're you should be okay. You'll have, how we did the 2 reciprocal functions up at the top. Your quiz has 2 of those on it. And then you've got 5 problems that you have to graph that are regular rational functions.
Like what we're doing right now?
Yes.
Is that it?
And then there's 2, like these 2 at the bottom.
Okay.
Your quiz looks almost exactly like this. My quiz is different.
So basically, it's just the first front back page.
It is this exact thing, except with different numbers. Okay. How are you feeling about that? Like number 3. Could you do everything that we just did?
I mean, I'd probably have to reference number 3 to do it.
Okay. All right. Let's walk through number 4. I'm just going to erase what I did with Braden earlier, okay? And walk you through it step by step so you know exactly how to plug everything in, okay? First thing that you want to do when you approach one of these, Garrett, every time is factor. So start there, okay? I don't know if all right. So can you give me the factors for the numerator?
6 and 1.
Yes. So I would have x minus 6, x minus 1, correct? All over x minus 6. Yes?
Yeah.
Okay. When something cancels numerator and denominator, which it does here because we got an x minus 6, correct? That makes it a whole. If it cancels on the top and the bottom, it is no longer a vertical asymptote. It is a whole. So since there's nothing left in the denominator, you would say there is no vertical asymptote. Okay? When the numerator, for the horizontal asymptote, when the numerator's degree is greater than the denominator, which there's an assumed 1 on that x, then there is no horizontal asymptote.
Wait, on the last problem, we got the VA from setting the denominator to 0.
Correct. We did. But this time it's canceled out.
When I did that, I got 6. It was because it canceled it out.
But because it canceled out, it's a whole and not a vertical asymptote.
Okay.
If it cancels, it's a whole and not a vertical asymptote. But you're absolutely correct. If it wouldn't have canceled, it would have been a vertical asymptote.
And also the degrees, if they're not equal, there's nothing there either.
If the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. Okay? So the horizontal asymptote is when you're comparing the degrees of the numerator and the degrees of the denominator. There's 3 references for the horizontal asymptote. If you still have your notes from graphing rational functions, it would be my suggestion to go back and review the horizontal asymptote, because if the degree at the top,
like, what if the degree of the numerator is less than the denominator?
The degree of the numerator is less than the denominator, it's y equals 0. If the degrees are equal, you take the ratio of the coefficients. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So there's 3 different references. So now, because this was a whole, what you have to do is take that 6 and plug it back into the simplified equation. That's the simplified equation. So I'm going to plug this whole, this 6, back into the simplified equation, okay? And that tells me that the y coordinate is 5. So I'll graph that at 1, 2, 3, 4, 5. 1, 2, oh, yeah, no, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This is my simplified function, which is really just a line. Y equals x minus 1. Remember good old y equals mx plus b? Those were the days. So I have a -1 as my y-intercept. I can actually set the numerator in the original problem equal to 0 for my x-intercept. My slope is 1, so I'm just going to head on up this way. And then I hit the hole. I cannot, and that's going to be a blank. So that's actually the graph of that rational. And for the domain and range on this, it's only that x can't equal the 6 and x can't equal the 5, which is the coordinate of the hole.
But how'd you get the x integer?
The x-intercept?
Yeah, sorry, I'm tired.
That's okay. I plugged in 0. I set the numerator equal to 0. That's what you do on every rational equation, is you set the numerator equal to 0. That also is on your notes from the graphing rational functions. There's a section at the very top of that page, Garrett, where it literally steps you through each of these things that I'm doing now. Do you see it?
Yeah.
Where it says simplify the function at the top, I would write right next to that factor and cancel what you can. Like give yourself a little note. And the step 2, find the x-intercept by setting the numerator equal to 0. Step 3 is find the vertical asymptote by setting the denominator equal to 0. And remember how I was talking to you earlier about the different cases for the horizontal asymptote? It's listed there. But please note that P and Q, if you want to make a note that says the degree of the numerator is greater than the degree of the denominator. So instead of P and Q, you might want to write N and D to remind yourself that it's numerator and denominator. Does that make sense? Okay. All right, so number 5. So the first thing that we want to do is simplify the function or factor. So the top is going to be x plus 4, x minus 4, because that's the difference of 2 squares, which I hope you're starting to pick up on those right away and notice those. And the denominator factors to be x plus 4, x plus 6. We can cancel something, correct? So that's going to give us a whole. Okay, so we want to remember that. If we're following the steps on the rational function, steps to graph, she says the next thing to do is find the x-intercept. So over here, we would set the numerator equal to 0. So that's going to be 4, 0. Because your y coordinate for the x-intercept is always 0. my vertical asymptote is going to be where I set the denominator equal to 0. So x plus 6 equals 0. X equals -6. The horizontal asymptote, we're going to check the case. The case, in this case, the numerator is equal to the denominator as far as the degrees, because the top is x squared and the bottom is x squared, right?
Is it just 1?
So it's just 1. Good job. Y equals 1. We do have a whole because we canceled a factor. So we want to do x plus 4 to find what that whole is. So it's -4. And to find the y coordinate of that whole, we'll plug in 4 into the simplified function. And what I mean by that is, what does this function simplify once I cross everything out? It goes to x minus 4 over x plus 6. So in order to find the whole, that's where we'll plug in that 4. Actually, it's a -4. I didn't get that circled very well when I circled it. So -4 minus 4 is -8 over -4. Did I do that right?
Wouldn't the whole be -4, -8?
That's what I'm thinking. Hold on. -4 plus 2 is a +2, yes?
I'm
If you
confused. Last time, just to get the last part of the whole, you plugged in what we already had and threw it into the numerator. -4 minus 4 is -8.
Yes, but that was because there wasn't anything in there. There was only the numerator. So this time you have to plug it into both.
Yeah, that would be -8 over 2.
Okay. I did do that right?
Yeah.
Okay, I'm just thrown. Okay. All right. I was like, okay. All right. So -4, -4. So we have a 1, 2, 3, 4. And x equals -6. 1, 2, 3, 4, 5, 6. I'm just graphing what I have now. And y equals 1. So I got my x-intercept in place. I want to draw my whole, -4. Get my hole in place. I want to remember that my domain can't be anything. Can't be my whole. And can't be my y. Of my horizontal asymptote. All right, now we're going to do our x and y table. And your critical point is that -6, right? For your vertical asymptote.
Mm-hmm.
And let's start plugging. And we know we also have a 4 and a 0, so that's always a blessing. We've already got it in place. Okay, so -5 is a -9. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1. Sorry about my table being ugly. I'm going to take this x-intercept off for now. -1 is -1. I need some big numbers. -7 is 11. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I go off the chart, don't I, there? So -8 is 6. Let me try that one. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So like right here. And then 7's going to be way up here.
Is this going to be taken up in class?
Yes. And -11 is going to be -3 or +3. So that's what your graph looks like. Don't forget your hole. My chi chart kind of rode down into number 6. Sorry about that. I was just trying to get some whole numbers, you know?
Mm-hmm.
Did you get that?
Yeah.
Okay.
Are there any of the others on this worksheet any harder? Or have any like good exceptions?
Yes. I wish I had better news for you, but when you're doing the T charts by hand, yeah, some of them, I mean, the vertical and horizontal asymptotes, nothing is hard on any of them. But when you're doing a T chart by hand, it's yeah, I was going to say it's kind of it's cumbersome, you know. But the vertical and horizontal asymptotes and the holes and the x-intercepts, nothing's very hard about that. It's just the T-charts can be, and I really sorry it took me a little longer on that one because I hadn't done very many of that particular one. I've got more done on number 6 and number 7. But number 7, the numbers are very small. But I at least have the T-chart done. I did not have the T-chart done before this, so I was having to hand do those while you and I were on Math Lab.
Can we just do 6, 7, 8, and 9?
Yeah.
And
do you care if I erase this T-table so that I can work on 6? Did you get everything that you needed?
Yeah.
Okay.
The thing is that these take such a long time to do. You know, I got other work to do.
I know.
Like if you could work the next pages, like and record it, that'd be great. But yeah. I mean, I just want to get through the first front back page.
Yeah, I got you. Well, I tell you what I'm going to do. I'm going to skip to number 7 since that was the one that most people ask about. And then I'll go back and do the others after you get off. But you probably should hang out for 7. And then I'll go back and do 6, and that will be in the recorded Math Lab.
Well, I would like 8 and 9 so I can figure those out.
Okay. All right. So number 7. Yikes. I can't get my paper to quit moving. Sorry. Okay. Going through the steps that are on our rational functions. Simplify the function first, which means factor, and, reduce if you can. So the factor on the top is I know I can factor out an x. And on the bottom, I can factor out a 3. Then that will further reduce to be x, 2 factors that give me -8 that multiply to give me a -2. That's going to be a -4 and a +2. And on the bottom, we have x plus 3, x minus 3, because that's the difference of 2 squares. Nothing cancels. Okay? So that means I'm going to have 2 vertical asymptotes. I set each of the factors in the denominator equal to 0. And that gives me... I'm sorry?
Does that mean there's no hole?
No, there's no hole on this one. Good job. You're getting it. So I'll go ahead and write that down since you noticed that. And with the horizontal asymptote, we compare the numerator in the top and the degree of the numerator and the degree of the denominator. The highest degree in the numerator is a 3. The highest degree in the denominator is a 2. When the numerator is greater than the denominator, there is no horizontal asymptote. To get the x-intercept, you set the factors that are in the numerator equal to 0. There's 3 factors in the numerator. There's an x factor, so that means there's going to be an intercept at 0, 0. And then we've got x minus 4. If we set that equal to 0, that would be 4, 0, because the y-coordinate for an x-intercept is always 0. And then if we set x plus 2 equal to 0, it would be -2, 0. So there's 3 x-intercepts. There is 2 vertical asymptotes. I'm just going to go ahead and give you the range is all real numbers. And the domain is all numbers except for x cannot equal 3 or negative 3. And now our XY table. Critical point, we have 2 of them. One at 3 and one at negative 3. And you can plug in all of your y-intercepts in there also. But I have another point of negative 4, and it is negative 3.05. And I also have a point of 1, which is virtually useless to me, but it's 1 and 0.375. Because basically what I'm trying to show you is this has a very weird shape. We've got a parabola in the middle. That runs through. And this actually has what's called an oblique asymptote, which we haven't, your class didn't really get into, but it makes it have a kind of a weird, these two have a very weird shape. And it looks like that. All of these numbers on that table they're all decimals when you plug them in. Like when you plug in -6 and all of that, it's all decimals. All right, I'm just going to do 7 and 8, and then I'll go back and do 6. Okay, the reciprocal parent function is reflected across the x-axis. The reciprocals, Garrett, are what we started with. So you've got, when it's reflected across the x-axis, it's negative on the top. So we know we've got a negative on the top. It's translated 5 units right. So if I'm going right, then, and the original was to do x minus h, you would just stick in that 5, okay? And then 7 units down. Oops, that's going to be -7. So the units right and left are opposite of what you think. And that's all in those original notes. So your answer is this. Okay.
Mm-hmm.
Number 9, let's just talk about what we know. We know a vertical asymptote is anything that makes the denominator 0. So if you have a vertical asymptote at x equals 3, then the factor for that is x minus 3 because it's the opposite. We know we have a hole at 1. So that's going to be x minus 1 on the top and the bottom because a hole is when it cancels, right?
Mm-hmm.
So the one thing that we're missing, it's got the x-intercept. The one thing we're missing is the x-intercept. So what factor would make us have a negative 9? Would be x plus 9. Because if you set x plus 9 equal to 0, it would give you a negative 9. And you get the x-intercept by setting the numerator of the simplified function equal to 0. So then you would want to FOIL this whole thing out because the last thing you're supposed to do is identify the horizontal asymptote. So you would FOIL the top, which would then give you x squared plus 8x minus 9 all over x squared minus 4x plus 3. So now we'll compare the degrees of the numerator and the denominator, and they're equal. So that means the horizontal asymptote is y equals 1. And I forgot to give it to you over here, the asymptotes over here on number 8. I apologize. The VA is x equals 5, and the HA is y equals negative 7. And for this one, the HA is y equals 1. Did you get those?
Yeah.
Okay. I've seen your quiz for tomorrow, and there's nothing as difficult as 7 on there. That is the hardest one, in my opinion, on all of mine and Miss Wynn's homework.
I have a question, Miss Sparks.
Yes, love.
So what are you gonna do after like I leave? Are you just gonna do like 6?
I'm just going to
and some
do
of the
number
other problems?
6. Yep.
Are you gonna do any on the next page?
Which one? The number 7?
Yeah.
I think I did one early in math lab, but I wasn't going to.
Well, it'd really be helpful because it's really time consuming.
Yes. But I think homework 7 is optional for you guys, according to the lesson plan.
Is it?
Uh-huh.
Oh, okay.
So you would
Oh,
only want to do it.
I think I remember her saying that it was like if you need extra practice.
Yeah.
Okay, then. Thanks, Miss Sparks.
Uh-huh. you can't set this denominator equal to, it would be 1 equals 0, which is not true. So that means there's no x-intercept on this one. And this is going to be fun, graphing 1/3 x. The horizontal asymptote is x equals 1/3. And the vertical asymptote is 1/3 and the horizontal asymptote is 0. Sorry about that. And then we have a hole at 5 and 1/4. So 1, 2, 3, 4, 5. And it's right in here somewhere. And my critical point is 1/3 where it's undefined. 0, -1. Yay, it's a real point. Praise the Lord. Want to make sure you pick up your pencil near your holes. And that's it for Math Lab, unless there's any other questions.
Yeah, Miss Sparks, do you think you could give me an example of a slant asymptote?
Oh, sweet girl, you've been waiting here that whole time, love. You're so patient.
Well, thank you. I thought I could use it anyways because I was like, I might as well just watch this to make sure that I know what I'm doing.
Yes, hey. And I know now Miss Wynn's class is going to hear this, so hopefully she won't be upset with me. But you were in class when we did the tables, right?
I think so.
Friday. It was a week ago Friday.
Yeah,
I
I was
can't
in
remember.
class then.
Oh, okay. All right. Okay. So I just wanted to, and I swapped over and I saw, and you asked that a long time ago, love. You're so sweet. I didn't see that till earlier. Yes, I can. What I did you get my, did you by chance get the, I tried to send the asymptote task cards to you and one other person who was absent. Did they come through to you okay? Because I was just going to use that if you don't care.
I think so.
All right. Well, I was just going to use those as examples. That's the only reason I'm asking.
Yeah.
Okay. I'm looking. I may go back to our email real quick.
I have class notes and then the teacher copied the class notes and then the homework number 8.
Okay, well maybe I didn't send it then. So let me upload it real quick because this will be the best way to show you, because all I'm asking you to do, and then I'm going to draw a picture of one, but basically all I'm asking you to do, and it's a bonus. And I feel like somebody else was going to watch this for that. So I need to post on there that it's at the very end of the video. And thank you so much for waiting through it.
Oh, yeah, you're welcome.
Let's see. Okay. Oh, I really didn't upload it. I thought I uploaded it. Are you feeling better?
Yeah.
Oh, good. Was this a good review for you?
Yeah.
Okay.
It made it better to like be able to see it all being worked out.
Oh, good.
Figure
I'm
it
so
out.
glad. I'm so glad to hear that. My computer is, of course, running very, very slow.
It's okay. Mine always does too.
It's only when people are waiting on something. You know what I
Yeah.
mean? It's like a watch pot never boils kind of thing.
When people are waiting for you, or if you need something to pull up super quick and it just won't.
I know.
And then you have all the time in the world, you go to pull something up, it pulls up right away. You're like, you couldn't do this on a
I
regular basis.
I know. I'm like, oh Lord, why? So how long does it take for it to update? If I, because I can't upload it from my computer to to this. So let's see if it updated. Okay, me and Alex are waiting. Oh my gosh. All right. It'll help if okay. So the test, just like for horizontal asymptotes, the test is if the numerator, if the degree in the numerator is larger than the degree of the denominator, then there's no horizontal asymptote. But in that handout that I gave you guys, there's a little like extra note where the 8 legendary steps, that I handed out. There's a little extra note when it talks about comparing the degree of the numerator and the denominator. And in that extra note, it says when the numerator is exactly 1 degree greater than the degree of the denominator, or it might list it vice versa, then there is an oblique asymptote. So like what you would say, like if I ask you on the quiz, identify the horizontal asymptote for number 6, you would tell me that there's no horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. However, there is an oblique asymptote. Okay. And the oblique asymptote, how you find that, and on number 7, when I kind of talked about the fact that there was one over here, is that Is this the weird one? No. This weird one right here?
Yeah.
There's an oblique asymptote that actually runs through here. And you find it using polynomial long division, but that's why it looks weird like that. We won't do real complicated ones like that. But over here on this one, I chose these because all you have to do to find it is synthetic division. So you basically would do 8 and then the coefficients 1, 3, -9. Bring down your 1. And then 1 times 8 is 8. So that's 11. And you can really stop right there. You don't have to go on any further than that. Because the remainder is not important. And it even says so on that worksheet. This is the part you want to focus on right here. And you would put it back x plus 11. So the oblique asymptote is actually a line, which is x plus 11. Okay? And number 8, when you compare the degrees, this wouldn't have an oblique asymptote because the degree of the numerator is greater than the degree of the denominator. So it has a horizontal asymptote of y equals 0. Okay?
Okay.
Down here, this one has an oblique asymptote. You would use synthetic division. Oops, I didn't leave myself any room. So this actually turns out to be y equals x minus 12. And the oblique asymptote is usually a line. And then on number 10, it would have an oblique asymptote. It would be no horizontal asymptote, but there would be one oblique asymptote. HAs are none, but there is an oblique, and you would do synthetic division again to get it. But you don't have to do that last part, like I said, because the remainder is not important. You only take the first two when you're able to use synthetic division. It's going to be a little more complicated next year, but this just dips your toes a little bit. So this one is x plus 12. The oblique asymptote is a linear equation.
That makes sense.
Good. And that's just what it looks like. It's not really more complicated than that. We had one on the homework where you actually can see it. It's pretty cool, but when you're graphing these and they turn out to be let me see. Let me write this one down. I don't know if you want to see it to make it clear or not. But it's pretty cool because when they come out to be a weird shape, I guess maybe I'll just go back to this one. Yeah. Notice how this actually how weird the shape is. All the rest of them have been pretty open like that. Like that. They're pretty open and wide. But this, because it's hugging not only some horizontal or vertical asymptotes, it's got this wicked looking oblique asymptote that it has to follow that line. So it makes that short curve, that real curve action to follow it. So it's not only hugging the vertical asymptotes, it's also kind of doing a weird thing as it runs into the oblique.
Okay.
Okay. And that's the point of the oblique asymptote, because you're like, wow, there's something kind of cool going on, and that's where the oblique comes in. But the bonus question will be like these, in that you will only tell me what the function is or the linear equation is of the slant asymptote.
So we'll be telling you like what the linear equation is, but we're not going to be graphing it.
No, ma'am.
Okay.
There's no graph on there. I would give something like this right here for you to find the key characteristics, which would be, you know, the horizontal asymptote, which in this case you would tell me none. You would tell me what the vertical asymptote is, which you would tell me here that it's -4. And then you would say, but there's a slant asymptote and it has a linear equation of, and you would write this down. But it actually, I have a little blank and it says slant asymptote. So you would just write in that linear equation that you found by doing synthetic division. Does that make sense?
Yeah.
Okay. Any other questions?
I think that's it.
Okay. All right. Well, email me if you have any other questions.
All right,
And
I will.
you feel okay about taking the quiz tomorrow, even as sick as you've been?
Yeah, I think I can do it.
Okay. All right. Just keep me posted.
All right.
All right. Have a blessed afternoon. Thanks again for coming to Math Lab.
You too. Thanks for hosting it.
No problem. Have a blessed day. Bye-bye.
You too. Bye.